Okay, so let's go through just the problems 1 through 3, which are just some reminders about how to simplify radicals that are going to be showing up in problems that we're dealing with using right triangles. So the first problem is not simplified because there's a radical in the denominator. So we have to start off by getting that out of there. So in this case, all we have to do is just multiply the bottom by the square root of 6 and also multiply the top by the square root of 6 just to balance out the equation. And on the bottom, it's going to say the square root of 6 times the square root of 6, which is just 6. And then 3 times the square root of 6, I can't put together, so I'm just going to leave it like that. Okay? And then we're going to look at these outside values. If you take a look at the 3 over 6, that's just a fraction. That's 3 over 6, which can be more simplified to 1/2. So I'm going to say, in this case, the square root of 6 over 2, right, with a little 1 sitting out here that we don't have to write, is the simplified version. Okay. The other thing that you're going to run into with some of these right triangle trigonometry problems is sometimes the radical will be there, but it will not be simplified because there's a perfect square in it. So I'm going to say for this one that the square root of 24 is 4 times 6, and I like that because the square root of 4 is just 2, so I'm going to say 2 root 6. And I can do the same thing with 800. 800 just got a slightly larger value in it, so maybe you don't recognize that this has actually got a 400 in it. It's 400 times 2, and 400 is perfect square. So for this one, you might notice that there's a smaller value. In this case, 100 jumps out pretty obviously because there's 2 zeros at the end. So what might happen with some of these larger radicals is you might do something like, oh look, it's the square root of 8 times 100, and I know that the square root of 100 is 10, and you'll look at that and say, look, I'm done. Okay, but we're not done because 8 still has another perfect square in it. In this case, that perfect square is a 4, so you might have to, a second time, break up the radical. Okay, and the square root of 4 is 2, so this really just says 10 times 2, which is 20. Okay, so it's entirely acceptable to just break down a big radical like the square root of 800 in 2 steps instead of 1. Instead of searching just for that one largest perfect square, you might want to just find 2 smaller ones, and it might make your life a little bit easier. Okay, problem number 4. Let's move into actually doing some right triangle trig. So they're giving us 3 sides, 2, the square root of 5, and 4, and they're asking us if the triangle is acute, right, or obtuse. Okay, and it's possible that we might say, you know what, it's actually none of those 3 because it's not a triangle at all. So let's just remind ourselves about that first, right? We had a rule that said, for example, if you had sides of 2, 3, and 10, that this could not be a triangle because when I add together the 2 small sides and check to see if it's greater than the third side, in this case it's not. So I would say that 2, 3, and 10 can't be a triangle at all. It doesn't exist. Okay. So for us, we're going to look at 2, the square root of 5, and 4. And first thing we got to check is, well, is the square root of 5 the big side or is it the middle side? If you do the square root of 5, it's a little bit bigger than 2. It's like 2.3 or 2.4. So if I do 2 plus 2.3-ish, right, when you do the square root of 5, let's see what the actual square root of 5 is, right? If I go type in my square root of 5, yeah, 2.23, right? So we'll just say about 2.3, right? If I add these together and check to see is this greater than 4, the answer is yes, it is. It's about 4.2, 4.3. So we're going to say yes, this is a triangle because the 2 small sides add up to larger than the third side. So now the question is it acute, is it right, or is it obtuse? Right? So the way to figure that out is to check and see, is the biggest side, C, in this case 4, which we're going to call C, is that equal to the other 2 sides in the Pythagorean theorem? Okay? So I'm going to say, is 4 squared equal to 2 squared plus the square root of 5 squared? So in this case, is 16 equal to 4 plus 5? And in this case, it's pretty obvious that 16 is not equal to 4 plus 5. So that means that this is not a right triangle because I did not, when I plugged into the Pythagorean theorem, I did not get equality. Right? So to check the other ones, right, we're going to figure out which inequality symbol fits here. If I plugged in the correct inequality symbol, I'm going to put a greater than symbol here. 16 is greater than 9. That's true, right? That's the one I want. So that's going to lead me to, in this case, saying that this is obtuse because of the greater than. And if it happened to have been less than, we would have said acute. Okay, so in this case, we're going to say it is a triangle. It's an obtuse triangle, which means one of the angles is bigger than 90 degrees, right? And we've completed the problem. And then just obviously explain, show all your work as to why that's true. Okay. Problem number 5. It's giving us a right triangle, and it's asking us to find x and y. And this uses the rules about 30, 60, 90, which let me just remind you right here what that says. Okay. If I have a 30-degree angle and a 90-degree angle, right, like we do, the other third angle that we haven't found has to be 60 so that I get my 180. So I'm going to add that to our triangle as well. Okay. So the general rule says if I call the short leg, which means the one across from the 30, if I call that x, that if I double that, I'm going to get the hypotenuse. Okay. So if you want to write that another way, I can say short leg, okay, times 2 is equal to hypotenuse. Okay. And then I can do the same thing and say if I take the short leg and I multiply it by the square root of 3, okay, I'm going to get the longer leg, which is across from the 60. So I'm going to say short times the square root of 3 is equal to the long leg. Okay, so we just have to look at our triangle now and say it looks like they gave us the long leg. So if I use this second rule that has the long leg in it, I'm going to say x, which represents the short leg, times the square root of 3 should be equal to the long leg, which they told us was 36. Okay, so we have to solve this and figure out what x is. Well, if I'm doing x times something and I want that something to go away, I'm going to divide both sides by it. Okay, and it's going to look like that. This will go away. So I found x, I found the short leg, but the problem is 36 over the square root of 3 is not a simplified radical for the reasons that we said in problem number 1. So I'm going to multiply the top and the bottom by the square root of 3, and I'm going to get 36 times the square root of 3 over 3, and this simplifies again because 36 over 3 is just 12. So x is equal to 12 square root of 3. Okay, that's the short leg. The other rule about the hypotenuse says you want to know what y is. Y is the hypotenuse. Well, that's just the short leg times 2. So I can just double the 12 and say in this case 24 times the square root of 3 represents the hypotenuse, right? So we have to know what the short leg is. Okay. Problem number 6. Problem number 6 looks very similar to problem number 5, right? They're giving us one piece of information and one angle, and they're asking us to find x, y. So I'm going to put a value here. I'm just going to call this x. I don't know what that is. Okay. So in this case, because this is not a special triangle, it's not a 30, 60, 90 or a 45, 45, 90 triangle, we're going to have to use trigonometry, which remember we have this shortcut that for the rules that say sine is opposite over hypotenuse, so cosine is adjacent over hypotenuse, ca, and tangent is opposite over adjacent. Right? So we say soca toa to remember the three ratios, sine, cosine, and tangent. In this case, if I label the three sides, x is opposite from 32. If I travel through the triangle over to x, okay, that's opposite. If I go to the leg that's right next to 32, that would be this wx side. This is what we call adjacent. Adjacent just means the leg that is next to. And then if I go across from the right angle, there's my hypotenuse, right? So in this case, if I'm looking at my picture, I see that I have information about opposite and the hypotenuse, and that is sine. So I'm going to set up the sine of 32 is equal to, well, the rule says opposite on top, hypotenuse on the bottom, so x over 11. And if I solve this by getting x alone, I'm going to multiply both sides by 11 to do that. Okay? And then the rest of it's just going to be on the calculator. So I'm going to go to my calculator, make sure I'm in degrees mode, so check your calculator, make sure you're in degrees mode, and I'm going to find out what the sine of 32 is. Right? So the sine of 32 to 4 decimal places is just 0.5299, okay? And then I'm going to multiply that by 11, and we're going to get our answer, which means that x is going to be about 5.8. It says round to the nearest tenth, which is 5.8 inches long, right? So we used our trigonometry, our SOHCAHTOA, to figure that out, okay? Problem 7, 8, and 9 are very similar to what we just did, so I'm going to say problem 7 is not a triangle at all, okay, because 2 plus 3 is not greater than 6, right? So that fails right away, okay? Problem number 9, we're going to skip number 8 because of the radical. That's probably the most challenging of the three of them. I'm going to say 2 plus 6 is greater than 6, so it's definitely a triangle. Can it make a triangle? Can we make a pod triangle with the side lengths? Yes, we can, because the two short sides add up to be larger than the third side. All right, and then we just need to check, is it acute, obtuse, or right? So I'm going to say, is 2 squared plus 6 squared, how does that compare to 6 squared? Well, it's pretty obvious in this case that 2 squared plus 6 squared is going to be bigger than 6 squared. This is 4 plus 36. 40 is greater than 36. So I'm going to say in this case that that makes this acute, because c squared is smaller than a squared plus b squared. Okay. Problem number 8. Again, I got to check first to be sure that when I add together these two expressions that I'm going to get something bigger than 6. And if you turn 3 root 5 into a decimal, okay, 3 root 5 into a decimal, it's about 2.23, right? So I'm going to put this in decimal form just because when I look at it like this, right, and add it to the other smaller side, I'm going to say, you know what? It actually doesn't work because when I add together 3 plus 2.3 or 2.23, I only get 5.23, which is not bigger than the third side. So this is also not a triangle. Okay? But if you don't turn that into a decimal, you're not going to be able to check and see that that is smaller. Okay? So be careful with that. Problem number 10. They're giving us a square with 12 inches for the diagonal, and they want us to find the length of BC, which is one of the sides. So I'll call this one x. And they want their answer in simplest radical form. So here's what I want to remind you about squares. Property of a square. If you draw a diagonal in a rhombus, which a square is a type of a rhombus, it bisects both of the angles, both of the vertices that it connects to. So this 90-degree angle that's sitting right here gets split into 45 and 45. And then the same thing happens down here, right? And so what we create in a square when we draw that diagonal in is two 45, 45, 90 triangles. So if we focus on this, again, here's your rule for 45, 45, 90. I'm going to say both of the legs that surround the right angle are the same. Right? So we're actually going to find all of the sides, which makes sense for a square. And I would call this one that leg times the square root of 2. So a way that we could write that is if I do leg times the square root of 2, I'm going to get hypotenuse. And in our picture, 12 is the hypotenuse of this right triangle ABC. Okay? So I'm going to say x times the square root of 2 is equal to 12. And here's that situation again. When you divide both sides by the square root of 2, you're getting a radical in the denominator that we're going to have to rationalize. So this is going to be the square root of 2 over the square root of 2. That rationalizes it. And that makes it 12 root 2 over 2. And there's that 12 over 2 that will simplify one last time. X is equal to 6 root 2. So that would be the simplest radical form of side BC. Okay, problem number 11. Okay, they're giving us one side of a triangle, okay, and they're wondering what is the value of y. Okay, so if they're saying if x is equal to 3, right, I can put a 3 here, what is the value of y? So I'm going to get rid of that. This is problem, don't forget that we also just did normal old Pythagorean theorem problems, right? These are the two legs of a right triangle, so I'm going to say, remember that a squared plus b squared equals c squared is the Pythagorean theorem, and in this case, a and b represent the legs, c represents the hypotenuse. So I'm going to say 2 squared plus 3 squared is equal to c squared, okay? That's 4, and that's 9, so this would be, 4 plus 9 is 13, is equal to c squared. And so if I square root both sides, there's your answer. It looks like the square root of 13 is the value for y, okay? Problem number 12, it says if, or they want to know, if we find x, if we solve this and find x, we can plug in and find out the value of 49 plus x squared, okay? So this is another Pythagorean theorem problem. It has nothing to do with angles, right? 45, 45, 90, 30, 60, 90, sine, cosine, and tangent all deal with some knowledge about angles, and we don't have any in this case. So we're going to use the Pythagorean theorem and say 7 minus x squared plus 7 plus x squared should be equal to 10 squared. A squared plus b squared equals c squared. Right, so I'm going to square these out. Be careful when you're squaring radical, or these polynomial expressions, that use 7 minus x squared actually means 7 minus x times 7 minus x, and then you're going to have to FOIL all this out. So this one FOILs into 49 minus 14x plus x squared. Okay? And then the same thing happens here. This one turns into 49. This is plus 14x plus x squared. Okay, oop, no parenthesis to close. Okay, and then on the other side, I'm just going to get 100 because that's 10 squared. So this left-hand side, we have to do a lot of combining. So 49 and 49 looks like 98. Okay, I got 100 over here on the right. X squared plus x squared is 2x squared. And negative 14x plus 14x is 0. These are going to cancel out. And so I'm going to get a problem that looks like this. Okay, so if I subtract the 98 over, now I get that 2x squared is equal to 2. That means that x squared is equal to 1. And if I square root both sides, x is equal to 1. right? So if I go up and answer their question now, what is the value of 49 plus x squared? Well, this is really 49 plus 1 squared. Well, 1 squared is just 1, so this says 49 plus 1, which is 50. Okay, so we found our missing expression, 49 plus x squared. Problem 13 and problem 14 are just direct applications of the rules about 45, 45, 90, and 30, 60, 90. So we know that if the leg is 7, that the hypotenuse is 7 times the square root of 2. If the short leg, which is across from the 30, is 10, the long leg becomes 10 root 3, and the hypotenuse just becomes 20. So that's just direct application of the rules in the simplest way that we can. Okay. Problem 15, it says you have a pool that is in the shape of a right triangle, right? And they want to know the perimeter of the pool. So in this case, we have to find a missing side. Again, Pythagorean theorem. I'm going to say x squared plus 150 squared is equal to 250 squared. Right? 150 squared, 150 times 150. Let me clear my calculator before I start calculating. 150 times 150 is 22,500. Okay? And 250 squared, 250 times 250, is 62,500. Okay? And I don't know what x squared is, so I'm going to leave that alone. So if I subtract 22,500 from both sides, it looks like I'm going to get that x squared is equal to 40,000. Right? And then if you square root 40,000, I believe you get let's do that. 40,000 square rooted, you get 200. Okay, so x is equal to 200. This is my missing length. Okay, so now I can find the perimeter of the pool pretty easily. 200 plus 150 plus 250 looks like it's going to be 600 inches. It's a very small pool. Okay, so problem letter B, it's asking us if you're putting decorative stone in a concrete around the pool's perimeter every 20 inches, how many decorative stones you need? Well, this is just going to be 600, my total perimeter, divided by the 20, okay, which it looks like that's going to be 30 stones. Okay, and then if each foot, it says you plan to put concrete around the pool. Okay, each decorative stone's $3.25, and each foot of concrete around the edge is going to be 80 cents. Right, so it looks like each foot of concrete, we got to be careful. If we have 600, let's see, it says you're going to put a decorative stone every 20 inches, right? So we need, it looks like, 600 divided by 0.80, okay? 600 divided by 12, so we can find the total number of feet, okay? We have 50 feet of pool, okay? Each foot, okay, costs 80 cents, so I'm going to say do 50 times 80. Right, so if I have 50 feet of concrete, which comes from 600 divided by 12, okay, 50 feet times 0.80, right, 80 cents, it looks like it's going to be $40, okay, for the concrete. And then we just figured out that we need 30 stones, right, so 30 stones times $3.25 per stone is another $97, okay, and 50 cents that we need to add on. And so it looks like our grand total for this pool is going to be $137.50. So again, the $97.50 came from taking the $3.25 times the 30 stones, right? So we just added those two values together, okay? Problem 16. This is asking us to find a missing angle, which is trigonometry again. So I'm going to label my sides. Opposite, adjacent. I don't need to go any further. That looks like the tangent property. That's my TOA. The tangent of x is equal to opposites 20 over 25, which is adjacent. Okay. Remember, we said in order to make tangent go away and leave the x behind, I'm going to do inverse tangent of both sides, and so that's going to leave an inverse tangent of 20 over 25. Okay. And so again, this is going under your calculator. So again, make sure you're in degrees mode. Okay. You're going to do 20 divided by 25, which 20 divided by 25 is just 0.8. Right. And then you're going to apply the inverse tangent. Okay. And it's going to tell you about, to the nearest degree, 39 degrees. 38.66 degrees rounded to the nearest whole number is 39 degrees. Okay, so it looks like we got a couple more problems left. Okay, so this problem is using 30, 60, 90, 45, 45, 90 again. So I'm going to forget about the whole left-hand triangle, and I'm just going to focus on this little one. Right, and this is the leg of a 45, 45, 90 right triangle. So that's going to make x equal to 4 root 2. Okay. Now I know the small leg of the 30, 60, 90 on the left here, and it says if you double the small leg, which for us is 4 square root of 2, that you're going to get the hypotenuse, which for us across from the right angle is the hypotenuse. That looks like z. So this is 8 square root of 2. Okay, and then if I, remember this is my 60-degree angle now because I have a 30, 60, 90 degree triangle here, okay, that if I multiply the short leg times the square root of 3, so my short leg is 4 square root of 2. If I multiply that by the square root of 3, that looks like 4 square root of 6. That's going to be my y value, right? So it's really, again, just using the two rules, or the two triangles, and using the rules in them to find our missing value. Okay, so problem number 18 is asking us to find an angle and to find a missing side. So to find the missing side, we can just use the Pythagorean theorem. I can say x squared plus 4 squared equals 8.1 squared. Okay, so 4 squared we know is 16. So this says x squared plus 16. 8.1 squared is going to be a little bit bigger than 64. 8.1 squared equals 65.61, which I'm not going to round. Okay, I'm going to subtract 16 off that. Okay, and that's going to leave me with 49.61. So I'm going to say x squared is equal to 49.61. When I square root both sides to the nearest tenth, I have about 7.0. So I'm going to say x is equal to 7.0. Right? 7.04 would probably be a better estimate because we know 49 exactly is 7. Right? So we might want to say leave an extra decimal point, but they only asked us for tenths, so we're good. Okay? To find y, we need to use our inverse trig problems. Okay? So we're going to say in this problem, okay, let me disable. Okay? We're going to say set up, in this case, a sine problem. This is opposite over here, and this is hypotenuse, okay? And so that looks like sine of y is equal to 4 over 8.1, okay? So again, this getting rid of the sine is using inverse sine, okay, of 4 over 8.1, just like we did with the tangent in the last problem. All right, so I'm going to do 4 divided by 8.1, okay? And then I'm going to use the inverse sine function. Again, make sure you're in degrees mode, and that looks like it's going to be 29.6 degrees, okay, rounded to the nearest tenth. So we'll say 29.6 degrees, okay? That would be rounded to the nearest tenth of a degree, okay? Problem 19 is another example of 30, 60, 90 showing up in the bottom triangle here, right? And so let's just solve this one, okay? But when we look at it, we're like, oh, well, I can't solve that one. I know nothing about that bottom triangle. So now we have to use a little power of deduction here and figure out what type of triangle I have up top. And in this case, we actually have another 30, 60, 90 triangle because I have a 90-degree angle here, okay? And if this is 60, this has to be the rest of it. And there's a 90, so this has to be a 60 up here, right? So it looks like I can solve this top triangle and then use this line right here, which is also part of the bottom triangle, to finish the problem. So it looks like I have the hypotenuse of my 30, 60, 90 triangle. And if you remember, we had a rule that said small leg times 2 is equal to hypotenuse. So if I know that my hypotenuse is 12, right, and it's going to be 2 times the small leg, okay, then it looks like the small leg in this case has to be 6. So I'm going to say this piece right here is 6. That's across from the 30. That's the small leg. And then we had another rule that says if you take the small leg and you multiply it by the square root of 3, that you'll get the long leg, which is the one that we want. This is 6 root 3. Okay, so we're going to do this again now. I'm going to look at this one and say, now I have the hypotenuse of this triangle. So the short leg is cut that in half, 3 root 3. Okay, and if I take the 3 root 3, just so you can see the radical calculation, and I multiply it by another square root of 3, well, the square root of 3 times the square root of 3 is just 3. So it's 3 times 3, which is going to make this one 9. Right, so I just applied the same rule twice in order to find x and y. Right. Last group of problems, 20 and 21. They're saying triangle PQR is a right triangle with acute angles P and R. So I'm going to draw that. Looks like this. Okay? Q is the right angle, and P and R are just acute angles. Right? So it's going to look like that. They're saying tan P is 1 over 3. What is sine R? So remember what tangent means. Tangent is opposite, okay, over adjacent. So I'm going to go to my triangle that we just drew. And I'm going to label from angle P, okay, that's what they asked about. They said tangent of P. I'm going to say that this side is opposite, this side is adjacent, okay, and PR is the hypotenuse, okay. So they told us that opposite is 1, okay, because that's on top of my tangent problem, and adjacent is 3, okay. And they want to know the sine of r. Well, remember, the sine of r is going to be equal to opposite from r over hypotenuse of the triangle. I don't even know the hypotenuse of the triangle, so we better find that. I know the legs of the triangle. That's going to be 1 squared plus 3 squared is equal to my hypotenuse squared. Okay, and so this looks like 1 plus 9, which is 10, is equal to my hypotenuse squared. And so it looks like the hypotenuse is the square root of 10. Okay, so now let's take a look at our triangle again, but now I'm going to be at R instead of P. So let me erase my labels. Okay, erase these 3. Okay, and I'm going to pretend now that I'm standing on R. I'm right here. Okay, we're also going to add in that this is now the square root of 10. Okay, opposite from R is 3, and the hypotenuse is what we just calculated. So the sine of R is going to be equal to 3 over root 10, which I'm going to let you do the work for this. It ends up being 3 root 10 over 10 when you rationalize it. Okay, so I'd say my answer to this one, 3 root 10 over 10. Right, so we have to do a little bit of work with that. When we had to find our own hypotenuse, we had to use the tangent ratio to put down some legs, right, and then we had to figure out what the sine of r was. Okay, all right, last problem. It says a woman is standing on a cliff, right, so let me draw my cliff. Okay, and she spots a raft down in the ocean, so there's a raft down here. Okay, and so she's looking down, okay, at the raft, like that. Okay, and it says the angle of depression is 7 degrees. Remember, the angle of depression is going to be the space from when she's looking straight to when she's looking down. So this is 7 right here. And her eye level is 18 meters above sea level. So if I measure from her eyes down to sea level, which is where the raft is, I have an 18 right here. Okay, so there's a triangle. And they want to know, based on this picture, what is the distance from the base of the cliff over to the raft. So they really want to know what is this measure right here. Okay, so if you remember, we said if I connect together the eyesight of the person with the eyesight of whatever they're looking at, or in this case just the raft, okay, that the angle of depression down from the person to the raft is the same as the angle of elevation from the raft back to the person. So that would be right there. So there's an alternate interior angles happening, and I can use that to get the 7 inside of the triangle. So if I want to find out what x is, I'm going to set up a tangent of 7, okay, is equal to opposite over adjacent. Okay, and we had a rule that said if you have a proportion, which we do, that you can switch the diagonal values in a proportion, and I can make this say x is equal to 18 over tangent of 7, and we just need to calculate that by doing 18 divided by, and I'm going to type in 7, hit my tangent button. Okay, and it looks like my answer is 146. Okay, does not say what to round to, so we'll just round to the nearest foot. We'll say 147 feet away, right? So angle of elevation, angle of depression are really just trigonometry problems. You just have to draw yourself a picture and make sure you label the angle of elevation and angle of depression in the correct spot.